I wanted to talk about number 2 in the homework because I saw something very interesting. I saw that many of you had different equivalent series to our original series. So let me bring up the pen. I'll tell you that these 3 series, these equivalent series, no, I kind of gave it away, they're equivalent. Right? These are all equivalent to this. They're all correct. Right? They all represent the same series as our original one. And if you wrote out all the terms in the red, green, and blue one, they are equivalent to the original one. But I saw that some of you had different values for what the series would converge to. Some of you said the red, for those of you who said the red one, it would converge to that one. For the green one, it converged to this one, and then for the blue one, it converged to that one. But why is that? Like, how is it that these 3 equivalent series are equivalent, but you guys said that the value that the series converge to are different? And in order to explain that, we have to go back to the definition of the convergence of a geometric series. So, for a geometric series, we know that as long as r is less than 1, it will converge. The geometric series will converge. And more precisely, it will converge to this value, a divided by 1 minus r, where we find these a and r values from the geometric series. When the geometric series is written like that, or when the geometric series is written like that, we can find our a and r value. So r, we know, is like the common ratio, and as long as the common ratio is less than 1, our geometric series will converge. And this a value right here, it's just in the series. So when we look at these different responses, the red, green, and blue, the r value seems to be the same. It's 5 over 7. You all agreed that the r value, the common ratio, is 5 over 7. So that's why all of you guys said it converged. But look at your a values. They're all different. The red one is 5 times 7 squared, the green one is 5 squared times 7, and the blue one is 5 cubed. So if you substitute these values for a into the equation for the value that a geometric series converges to, of course they're going to all be different. So why is that? I'm going to do the Khan Academy thing. I'm going to ask you guys to pause and try to determine that. Like, look at the definition of the convergence of the geometric series, right? There's something here that explains why we all got different answers. So I hope all of you guys pause. Okay, so hopefully you guys put in the work and saw that we can't just willy-nilly substitute in this value of a into this equation. We have to understand what it is and what it represents. So let's look at it. Let's look at this one. Let's write out what this series would be. All right, I always like writing out the terms. Right, so the sum from n is equal to 1 to infinity of a times r to the n minus 1. Let's write out the terms. When n is equal to 1, 1 minus 1 is 0. So r to the 0th power is 1, and then a times 1 is just a. So if I substitute in 2, r to the 2 minus 1 is r to the 1st power. And then this a value is still there. Let's look at the second one. It also says that when n is equal to 0 to infinity, a times r to the n would converge. So let's substitute in those values. So when n is equal to 0, r to the 0 is 1 times a, would just be a. When we substitute in 1 for n, r to the 1 is r to the 1, and that a value is still there. The thing that we have to keep in mind is that the a value is the first term in the geometric series. So when we are substituting these values into this equation over here, we can't just pick and say like, oh, this is a, this is a, and this is a, right? It can't just be the number that's next to our geometric series. Our a value is the first term in the geometric series. So let's take a look at the red one, for example. So for the red one, we said that from n is equal to infinity of 5 times 7 squared times 5 to the n over 7 to the n, our first term, if we substitute n is equal to 2, would be, no, that's the square, 5 times 7 squared times 5 squared over 7 squared. That's our first term. So this is our a value. And after we do some simplification, this would be 5 cubed. Let's try for the green one. Okay, so the green one is the same thing. Well, it's a little bit different, but if I can remember it, it's from n is equal to infinity of 5 squared times 7 times 5 to the n minus 1 divided by 7 to the n minus 1. What's the first term in this representation of the geometric series? Well, this 5 squared times 7 is still there. If I substitute in 2, 2 minus 1 is 1, so that's why this is multiplied by 5 to the first divided by 7 to the first. This is our a value. So this, after some simplification, this would be 5 cubed. And you can see now that the a values are all the same. They should all be the same because it should be the first term in the series. So if we were to plug it into our equation for the convergence of the geometric series, it would be 5 cubed divided by 1 minus 5 over 7.